harder today. One of the things you have to be able to use today are your 30, 60, 90, and 45, 45, 90 relationships. So once again, I'm stressing you have to have those memorized in order to work the problems. And some of you still on the last test did not have those memorized. So let's review our formulas. Write these down in your notes. And this warm-up should be in your notes. So make sure you're back on the front of your notes working this with me. If I have a 45, 45, 90, what do we call the two legs? L. What do we call the hypotenuse? L square roots of 2. Okay, if I have a 30, 60, 90 triangle, what is the side across from the 30? L. What's the side across from the 60? L square roots of 3. And what's the side across from the 90? 2L. Be very, very careful. One thing I haven't said that might be helpful, because some of you keep putting L square roots of 3 over here. One thing that might help you not make that mistake is to notice that both the hypotenuses have an L and a 2. They have an L and a 2. It's just one of them is 2L and one of them is L square roots of 2, but none of them have a 3 on them. So be careful that you're not putting this L square roots of 3 over here. They both have an L and a 2. It's just which one is which. Okay, and each triangle only has one square root. So you're not putting the square root of 3 and the square root of 2 in the same triangle. All right, let's work these problems. A 30, 60, 90 triangle has a hypotenuse of 2 feet. Find the unknown side lengths. So first thing I would do on my paper is draw my little triangle. 30, 60, 90. The hypotenuse is 2. Excuse me. And we're trying to find the other two sides, right? So what's the first thing we do to try to figure this out? Be careful. L squared of 2 is in the 45. So the first thing we talked about doing way back in this chapter when we learned this was label your formula around your picture. What's across from the 30? L. What's across from the 60? L square roots of 3. What's across from the 90? 2L. So we're going to set 2 equal to 2L. And then we're going to solve for L. What do we do to solve for L? Divide by 2. So what is L? L is 1. If L is 1, then what is the side across from the 30? 1. So when it says find the unknown side lengths, we know that one of our sides is going to be 1 what? What are our units? Feet. So 1 foot. The other side is across from the 60. If L is 1, what is the side across from the 60 going to be? 1 square roots of 3, or you can just put square root of 3, and your units are feet. So the two answers should be 1 foot and square root of 3 feet. Okay, very important for today that you can work with 30, 60, 90. So if you're lost anywhere, make sure you ask me. Now we're going to switch to the 45, 45, 90. So first thing we're going to do is draw our triangle. 45, 45, 90. L and L on the legs and L square roots of 2 on the hypotenuse. According to the problem, we have a leg that has a length of 4. So what's going to be 4 in our picture here? L. The leg is 4. So if the leg is 4, then the other leg is 4. 4 what? Inches. And then all we have left to do is find the hypotenuse. If L is 4, then what is the length of the hypotenuse? 4 square roots of 2. We're just plugging that 4 in for L. So 4 square roots of 2, what are the units? Inches. And that will equal the hypotenuse. So the other leg is 4 inches and the hypotenuse is 4 square roots of 2 inches. You don't on this little warm-up, but on the work we're doing today, it won't be the same kind of thing. We're not just finding these sides because we already learned that. We're going to be using this to find something else. Okay. All right, 30, 60, 90 again. You guys go ahead and try that one on your own and we'll check it. Notice it says the longer leg has a length of 3. What's the longer leg? Okay, the side across from the 60. You have a leg, you have a longer leg, and then you have a hypotenuse in the 30, 60, 90. This is the hardest one. Let's see how you're doing. We're not using our calculator. All answers should be in simplest radical form, so don't type your square roots in. Raise your hand if you're stuck. Okay, let's talk about it. So what goes across from the 30 again? L. So over here we have L. What's across from the 60? L square roots of 3, but they told us that the longer leg had a length of 3. So remember that you have across from the 30 is going to be your shortest because it's the smaller angle. The bigger the angle, the longer the side across from it. But we don't call the hypotenuse a leg, so it's not the 3 because it's the hypotenuse. So what's across from the 90-degree angle? 2L. All right, take the side that had the number on it and solve for L. That's a little harder, but we did ones like this back when we learned this. If we want to solve for L, and we know L squared to 3 equals 3, what do we do to solve for L? Can't square it because that's going to give us L squared. We're trying to get L by itself. Divide. Right now, L is being multiplied by the square root of 3. The opposite of multiplication is division. Think back to Algebra 1. When you learn to undo things, you do the opposite operations. So those cancel. We have L equals 3 over the square root of 3. Are we allowed to leave a square root in the denominator? Nope. What did we say to do to get rid of that square root? Multiply by the square root of 3 over the square root of 3. The reason we can do that again is because that makes a value of 1, and multiplying by 1 doesn't change your number. So we multiply straight across. What is 3 times the square root of 3? Just 3 square roots of 3. What's the square root of 3 times the square root of 3? It's 3 because it's the square root of 9, which is just 3. Do we leave our answer like that for L? What can we do to simplify that? To cancel the 3's out. 3 divided by 3 is 1. So this is just the square root of 3. So that was the value for L. The question said find the unknown side lengths. So one of our side lengths was L. So one of our side lengths is square root of 3. But what are our units? Meters. The other side length is 2 L's. So what is our other side length going to be? 2 square roots of 3 meters. So we had the square root of 3 meters and then 2 square roots of 3 meters. Questions on special right triangles? Okay, so we're going to learn 2 new formulas today. We're still dealing with area. Some of the things that are in the lesson today are things that we already talked about. Circles are going to be in this lesson today. We already talked about the formulas for circles. So I'm going to go through that part pretty quickly because that's probably the easiest part. And then we're going to talk about what is the center of a circle, what's the center of a regular polygon, what is an apothem, that's a new word, and then what's the central angle of a regular polygon. All right, so first we're going to start with the circles. And again, you should know most of this. You learned about circles a long time ago before you ever came to geometry. A circle is the set of all points in a plane that are a fixed distance from a fixed point. In other words, if I have a point on my paper and I go out a fixed distance, and then I plot all the points that are that fixed distance from the center, that's going to give me a circle. What is that fixed distance called in a circle? The radius. So the definition for a circle is it's all these points that make up your circle. That fixed distance is just the radius of the circle. And the center is the point in the middle that your radius goes from. Okay? A circle is named by this symbol. So when you see this symbol, that's what they're going to use to name a circle. So we would call this circle, and then you name it by its center. So we would call it circle A. Okay, so if you're naming a circle, you're going to name it with a little circle and a dot in the middle, and then pick the center. So this would be called circle C. All right, we already know what a radius is and what a diameter is. So name one of the radii in this picture. CA, what else? AD. And again, naming a segment, you can name it either way, so AC or CA doesn't matter. What is the diameter in the picture? CD. And we already talked about that it takes how many radii to make one diameter? 2. So there's 2 radii in one diameter. That is why we can talk about our circumference with 2 formulas. And so they just go through and talk about the irrational number pi. If you've never been presented this before, the number pi is found by taking a circle's circumference and dividing it by its diameter. Any size circle, if I took the clock on the wall and found the circumference and divided it by that clock's diameter, it would be exactly the number pi. If I took a very tiny circle and found its circumference and its diameter and divided them, it would be the number pi. So pi is the ratio of a circumference to a diameter. And it is irrational, meaning it goes on forever. We are not going to ever use 3.14 in here unless the directions specifically say use 3.14, okay? We are either going to leave our answer with pi in it, or we're going to use the pi key on your calculator. Does everybody know where the pi key is on your calculator? Look right now, make sure you do. If you don't, raise your hand so I can show you. So when you are at home doing your homework, there is a pi key on your phone. There is a pi key on a scientific calculator. So if you don't have access to a scientific, you don't have a phone, make sure that you come in and do your homework in Encore at some point before it's due, or see me before you leave and I can check you out a little cheap scientific calculator. Everybody find pi? Okay, so not using 3.14 unless the book tells us to. Otherwise, we'll use our pi key. All right, so in your notes here are your 2 formulas that we wrote on the board. Circumference is pi d and circumference is 2 pi r. And again, those should be added to your formula list that we made the other day. All right, and then they're going to go through and just try to get you to understand where the formula for area comes from. They go through this little chart and show you that if you were to take and break your circle up into little sections, like little pieces of pie, and line those up like this, it starts to look like a rectangle or a parallelogram. And if you did that, the base would be pi r, which would be this part going around the circle. And this would be the height, which would be the radius of your circle. And if you take pi r times r, that is pi r squared. So they're just trying to show you how they came up with that formula. We already know the formula for a circle, so I'm going to kind of go through that pretty fast. Again, here are your formulas for circles. Okay, so we're going to jump right into some simple circle problems. Again, the circle is going to be the easy part today. It's the regular polygon that's going to be the hardest. All right, so it says find the area of circle K in terms of pi. The area of circle K in terms of pi. Be really careful when you look at your pictures. Sometimes students get confused on, are they giving me the radius or the diameter? If they write the information right by the center and they have the whole diameter drawn, then they're giving you the diameter. If they're not going to give you the diameter, then they'll shift it so that it's like over here just down below the center, so it's talking about that one little radius. Or they'll shift it over so that it's centered in between here. But this is giving you the diameter. Okay? What's the formula for area? And like I told you last class period, start with your formula. Start with your formula, then plug in your information. So if the diameter is 6, what would we do to find the radius? Divide by 2, because remember, the diameter is equal to 2 radii. So we're saying that 2 radii are equal to 6. So we divide by 2, and r is equal to 3. Plug that into your formula. Notice your directions. What does it say to do? In terms of pi. So when it says that, my advice to you is to treat pi like x. Treat it just like you would a variable until you're ready to type it into your calculator. So could you do anything here to simplify this? What could we do to simplify it? 3 squared. What is 3 squared? 9. And so you're just going to leave your answer as 9 pi. Treat it like an x. You wouldn't say x9, right? That's kind of weird. At this point in our math career, we know to say 9x. So you wouldn't say pi 9, you would say 9 pi. So put it at the end of your number. 9 pi, and then do we have units in our picture? Inches, so it's going to be 9 pi inches squared because it's area. If it says leave it in terms of pi, you're not grabbing your calculator to type in pi. You're leaving pi in your answer. Treat pi like you would an x, do everything you can, and leave the x or the pi at the end. Questions? Okay, moving on. So this one's a little bit harder. It says find the radius of circle J if they give you the circumference. This goes back to like what we did in the last assignment. What formula do we want to start with here? Good. We're talking about circumference, and we want to find the radius. So I would use circumference equals 2 pi r. It's easier than doing pi d because we're not trying to find the diameter, we're trying to find the radius. Okay, what do they give us? Circumference. Be very careful. Where a lot of students make a mistake is they forget and they don't see this little pi right here. Make sure you include the pi when you plug it into your circumference. So this is 65x plus 14 pi equals 2 pi r. And what are we trying to solve for? The radius. So what do you think we should do to start trying to get r by itself? We could divide by 2. If I divide by 2, remember that you have to divide each term by 2. So when I divide by 2, what's 65 divided by 2? 32.5x plus 7. And we still have that as all multiplied by pi, and it equals pi r. Everybody okay with that? Okay, then what should we do to try to get r by itself? Divide by pi, and we could have divided by 2 pi all at once if we wanted to, or we could have divided by pi first and then divided by 2. It's up to you. Doesn't matter which order you divide in. So if I divide this by pi, what's going to happen to the pi's on the left and the right? They're going to cancel out. So the pi's cancel here, the pi's cancel here. So what does that leave us for the radius? Very good. And it doesn't say in terms of x. I will try to be very clear on the homework and put in terms of x anytime you're going to have an x in your answer. But you're just going to have to know on the homework. If you end up with an x, it's okay if you had x's in your problem to start with. So don't worry about that. 32.5x plus 7. And what are the units in the problem? Meters. And we're just finding the radius, so it's not squared. Questions on that one? Okay. Moving on to the next one. Find the circumference of circle M if the area is given. So what do we want to start with? What formula? Say it again, Tate. Okay, we want to find the circumference, which is 2 pi r. Make sure you put C equals. Do we know the radius? No, so we are kind of stuck. This is very similar to one of the questions we did last class period as well. When you write down the first formula they ask you to find, if you don't have enough information, keep reading your problem. What else do they give us in the problem? The area. So now we're going to switch to the area formula. What's the area formula for a circle? Pi r squared. What do they give us in this problem? The area, the A, so we can plug this in. Again, I would warn you to be really careful that you see that pi in the work there. So it's 25x squared pi equals pi r squared. Okay, we want to solve for r so that we can find our circumference. That's the only thing we need is the radius. So what could we do over here to start trying to get r by itself? Divide by pi. And what's going to happen to the pi's on both sides? They're just going to cancel out. Does everybody see that? We're just dividing by pi to get rid of pi. So we have 25x squared equals r squared. What do we do to get r by itself? Take the square root. So I'm going to take the square root of both sides. The square and square root cancel on the right, so we have r equals. And then be really careful here. What's the square root of 25? 5. What's the square root of x squared? X. Keep in mind, if you're confused by that, you could factor it and look for pairs. So the factors of 25 are 5 and 5. What are the factors of x squared? X and x. So if you get a little confused by the variable, factor it and then look for pairs. You've got a pair of 5s and a pair of x's. So both of them come out front, 5x, and you don't have anything left to go back under the square root. So it's just 5x. Units, feet. But this is not our answer. This is just the radius. We want to go back and find the circumference, right? So now we're going to plug that in. 2 times pi times 5x. Can we simplify that at all? That would put the 2 over to the circumference, and we're trying to find the circumference, so we don't want to divide, but could we simplify this right side at all? Is there anything we could do to make that a little simpler? Multiply the 5 and the 2. What is 2 times 5? 10. When you write your answer, put your answer in order. Think about it. Which one of these, pi or x, is a number? Pi is an actual number. So instead of putting 10x pi, you're going to put 10 pi x because you always put your numbers in front of your variable. It's not really wrong if you don't, but it's just not correct math notation. So go ahead and simplify anything you can simplify, but at that point, there's nothing else we can do unless it tells us to round. If it says to round, then we would grab our calculator and type in pi. It does not say to round, so we just put 10 pi x. And what are our units? Feet. Not squared because you're not finding area. Oops. So 10 pi x feet. Questions on circles? Okay, again, that algebra is thrown in, and that's sometimes the harder part for students is if their algebra skills aren't that great. All right, I already talked about this. We are going to use our pi key. We are going to wait to round until the last step of our problem. Never round in the middle of your problem. Always keep your total answer in your calculator. Okay, we are going to do part of this, but not all of it, so that we can move on. Read this with me. It says a pizza making kit contains 3 circular baking stones with diameters 24, 36, and 48. Find the area of each stone. We're going to do one. And then once I see we can do one, we'll stop. And you could do the other 2 on your own. So we've got 3 baking stones. And they're all different sizes. This one is a diameter of what? 24. Remember, your diameter goes all the way across your circle through the center. So if it's 24 centimeters for the whole diameter, what's the radius? 12. Does everybody agree with that? Just cutting it in half, right? It takes 2 radii to make 1 diameter. If this one has a diameter of 36 centimeters, what would be the radius? Careful, that's 32. What would it be? 18 centimeters. And if this one has a radius of, or excuse me, a diameter of 48 centimeters, what's the radius? 24 centimeters. Okay, I'm going to set each one of them up, but we're not going to actually work and find the area of all of them. Does everybody see how we found our radius, though? Okay, question says find the area and round to the nearest tenth. So we're going to practice with our calculator. We'll just find the area of this first one. What's our formula for area of a circle? Pi r squared. And the more you write it, the more you say it, the more you're going to memorize it. What's going to go in for r? 12. And what can we do here to simplify? Before I use my calculator, what could I do to simplify? Square 12. What is 12 squared? So I would have 144 pi. If it said leave your answer in terms of pi, you would stop here. But because it says round to the nearest tenth, you can grab your calculator and type in 144 times pi. Tell me what you get to the nearest tenth. 452.4? 0.9? 0.4? Okay, 452.4. Is that correct? Everybody agrees? And units? Centimeters squared. Good. It's area, so don't forget to square your units. All right, guys, that's as hard as the circles get. Any questions on circles, whether you're working backwards, forwards, finding the radius, finding the diameter, finding the circumference? All right, we're going to move into the harder part. And first thing we're going to have to do, I'm going to make up a separate example before we move into this, and I want you to add it to your notes because it's going to make your life a little bit easier. So add this to your formula sheet. This is our 5th new formula. Technically, it's the 6th because we have 2 for the rhombus. 5th new formula for a special kind of triangle that is not in our notes right now, so I'm going to make up a separate example. If you have an equilateral triangle, it has a special formula you can use to make your life easier. You don't have to use this formula. You can go back and use the formula for area of every triangle, 1/2 base times height. But I'm telling you, if you can take the time to memorize this formula, it's going to make your work so much easier. So if it's equilateral, remember that means that all 3 sides are equal. And what did we learn about equilateral triangles also? Their angles are also equal. So if it's equilateral, it's also equiangular. Here is your formula for that. A equals side, actually, sorry, don't write that. A equals, yes, write that. Side squared, square roots of 3, all divided by 4. Side squared, square root of 3, all divided by 4. Okay, I want to show you why this is easier, and I'm going to make up an example over here on the board. So let's say that I have this equilateral triangle, and I want to find the area. If I use my little shortcut over here, A equals, I would add this to your notes because this is really helpful. A equals s squared, square root of 3 over 4. The only thing I have to know to find the area is the side length. What's the side length according to my picture? 4. Plug it in, we have 4 squared, square roots of 3 over 4. What's 4 squared? 16. Simplify, you have 16 square roots of 3 over 4. What else could you do there to simplify? Say it again. The 16 divided by 4 reduces to what? 4. So we just get 4 square roots of 3. And that would be our area. Do you see how easy that is if they give you the side length? And it's equilateral. Only equilateral triangles will this work for. Not isosceles, not scalene. But if you know the side length, you just square the side length, multiply by the square root of 3, and divide by 4. But you have to memorize the formula. If you're not going to take the time to memorize the formula, then you'll have to work it this way. So let's work it the hard way. What's the formula for area of any triangle? 1/2 base times height. Okay, so if I didn't know this formula, what do I know in terms of base or height here from my picture? The base. What's the base? 4. Do I know the height? No, I would have to draw it in. So when I draw in my height, what does that do since this is equilateral to this base? Splits it how? Okay, 2 congruent pieces. So what's the length of this piece? 2. And what's the length of this piece? 2. Then you're going to have 2 options to find your height. One option, what could we do? Pythagorean theorem. So we could do Pythagorean theorem, but then we have to do the Pythagorean theorem before we can find our height. So I would have 2 squared plus h squared equals 4 squared. Is everybody with me that we're just doing Pythagorean theorem on one of these little triangles to find our height? Okay, what's 2 squared? 4 plus h squared equals 16. Then what do we do? Subtract 4. So now we have h squared equals 12. Then what do we do? Take the square root. So h equals the square root of 12. Then what do we have to do? Factor it. So what does 12 factor into? 4 and 3. What does 4 factor into? 2 and 2. So we have a pair of 2's and 1 3. So what does that make our height? 2 square roots of 3. So then we come over here and we plug that in, 2 square roots of 3. Is this making sense so far? Okay, then we multiply. What's half of 4? 2. What's 2 times 2? 4. So we get 4 square roots of 3. But we had to do the Pythagorean theorem, and we had to draw in our height, and we had to divide that base before we could get it. Do you see how that's a little harder? Okay. Or instead of doing Pythagorean theorem, you could have used your special right triangles. Because what do we know that every angle is if it's equilateral? 60. They're all equal. So that makes each of these triangles a 30, 60, 90 triangle. So you knew this was 4, which is across from the 90, which would have been 2L, which would have made L equal to 2, which across from the 30 is L, which would have made L 2, and then across from the 60 is L square roots of 3, which would have made this 2 square roots of 3. So you could have used that to make it a little faster. What I need to know is, do you understand one of these 3 different ways you could have worked this problem? How many of you liked the black method, memorizing the formula? Okay, but then you have to commit to memorizing the formula. If you don't memorize the formula, you're not going to be able to get it right. So you've got to add that to your list over here. This will be on your formula test. So memorize it, okay? All right, now we're going to move into this new concept. It's area of a regular polygon. There is one formula, but there are some shortcuts for specific shapes. And so I'm going to try to show you the easy ways and then show you the way that works every single time, okay? But first you have to understand some vocabulary. So the center of a regular polygon. First of all, remind me way back, what did regular mean? It is going to be closed, but that's not what regular means. All the angles are equal and all the sides. Remember that regular means, so you may have to add this to your notes if you've forgotten, equiangular and equilateral. Okay, so we're going to go through on our regular polygon and we're going to learn these new vocabulary words. So I'm going to draw the easiest one to do, which is probably, actually I'm not going to draw the easiest. The easiest would be an equilateral triangle, which is regular, or a square, which is regular. But I'm going to draw one that we don't have a formula for. Okay, let me say this again. Does everybody understand that a square is regular, equilateral and equiangular? But it's probably easier to do it just by doing side squared, this formula. And that equilateral triangles are regular. But it's probably going to be easier to do it by just using this formula, s squared square roots of 3 over 4. What we're going to learn today is, how do I find the area of a 5-sided regular shape? What's a 5-sided shape called? pentagon, or a 6-sided regular shape, hexagon, or a 7-sided regular shape, heptagon, or an 8-sided, octagon, 9-sided, nonagon, 10 sides, decagon, and the last one, 12 sides, dodecagon. Okay, again, that's stuff that we learned before that you need to know because it'll be on your homework today. So we're going to figure out how do we find the area of those shapes, okay? So we need to know some vocabulary first, though. The first word we need is regular, which we understand means now that all the sides and all the angles are going to be congruent. We are only finding the area of regular polygons in the rest of the notes today, only regular ones. The apothem is going to be the distance from the center to a side. Well, first of all, what's the center? The center of your regular polygon is going to be the point that is the center of the circumscribed circle. So if we were to draw a circle around that touching every vertex, this center of that circle is the center of your polygon. The apothem is going to be the distance from the center to the side. Okay, now think about this with me. When we draw distances, do we draw distances diagonally or vertically perpendicular? Vertically perpendicular. So your apothem is always going to go from the center vertically perpendicular to the side. So this would be your apothem A. Is everybody with me? You could go to any side of the shape. So I could go from here over to this side vertically perpendicular, and that would be the apothem. So from the center to a side perpendicular is apothem. Any questions about the apothem? Okay. Central angle of a regular polygon. Some of your homework is just going to say find the central angle. It's not going to say find the area of anything. Just find the central angle. The central angle of a regular polygon has its vertex at the center, and its sides pass through consecutive vertices. Okay, that's kind of wordy. Let me show you what they mean. So central angle is going to have its vertex at the center. Maybe. There we go. And its sides are going to go from the center to 2 consecutive vertices. So let's say I go to here. Come on. And then another consecutive vertice would be right after it, so from the center over to there. This angle is a central angle. If this has 6 sides, how many central angles can I make? How many? 6. Are you guys seeing all 6 of those? So 1, 2, 3, 4, 5, 6. How many triangles did I just make? 6. How many degrees are there in a full circle? 360. So does it make sense that if I want to find the measure of one of these central angles, and all 6 of them put together makes a circle, that we can just do 360 divided by the number of sides? So what would be the central angle for this hexagon here? 360 divided by 6, which is 60. So however many sides you have, that's how many triangles can be formed, and that's how many angles you're going to have inside your polygon. So let's say I had a 5-sided figure. What's a 5-sided figure called again? Pentagon. So here's a pentagon. So if I were to draw my center and every central angle, there's a central angle, there's a central angle, there's a central angle, there and there. Do you see how I have 1, 2, 3, 4, 5 triangles? And that all 5 of those central angles together makes a circle? So our central angle would just be 360 divided by 5. 360 divided by however many sides you have. That's how you find your central angle. And what's 360 divided by 5? 72? 72 degrees. Questions? Everybody understands how to find a central angle and what it is? Everybody understands that the apothem goes from the center to the side perpendicular. All right. So we're going to start with trying to find the area of a regular polygon. Okay, I'm going to show you where this formula comes from so you'll understand it a little better. Because this is the formula that you're going to need to memorize. But if you don't really understand where it comes from, it makes it a little bit harder. So I'm going to go back to my picture of my hexagon. Okay, and in my hexagon, oops, how many triangles did we say we had? 6. So would you agree with me that I could find the area of this hexagon by finding the area of one triangle and multiplying it by 6? Okay, you could do that for every regular polygon, but it's going to be the hardest way to do it. Okay, but for your problem, you could do the area of a triangle times 6 because there's 6 of them. All right, I'm trying to go slow to make sure everybody's following me. Area of a triangle we know is 1/2 the base times the height, right? Times 6, because we have 6 of them here. Are we all following that? Okay. What do we call these things here that make up our hexagon? What do we call each of these? A side, right? Would you agree that that side is the base of one triangle? Okay, so where I have the letter B, is it okay if I put S? Okay. So I have 1/2 of S times the height times 6. Are we okay with that so far? Okay, the height of the triangle is going to go from here straight down, perpendicular. What did we just call that? We gave it a new name today when it was inside our polygon. Apothem. So do we all agree that the height is the same as the apothem? Okay, so where I have the letter H, can I put a little A for apothem? Okay, so now I have 1/2 S times A times 6. Okay, now I'm going to rearrange the order of those letters. Since it's all being multiplied, the order in which we multiply them doesn't matter. So I'm going to take the 6 and the S. And so I'm going to rewrite this as 1/2 A times 6S. Is it okay if I move the S and put it with the 6, since we're just multiplying? What would we call 6S? If I found S, 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 what is that called when I take 6 S's? The perimeter. Do you guys see how that's just the perimeter of the hexagon? So instead of putting 6S, is it okay if I just put a capital P for perimeter? And now here's your formula. 1/2 apothem times perimeter. It's the shortcut to finding the area of a regular polygon. Long method would be to find the area of one triangle and multiply it by how many triangles you have, which is basically what you're doing. So in a pentagon, I could find the area of one triangle, but I would multiply it by how many? Ruben, stay with me. How many triangles are in a pentagon? 5. So it'd be area times 5. But this is our shortcut, and it says all you need to know is the perimeter and the apothem. And then just do 1/2 apothem times perimeter. Take your formula sheets and add your last formula. This is the last one. Area of a regular polygon. It equals A equals 1/2 little a times capital P. 1/2 apothem times perimeter. Little a times capital P. 1/2 apothem times perimeter. It's right here on the board. It's also in your notes if you can't read it up there where I'm at. Okay, 15 formulas on the board that you need to have memorized, and those are the only formulas on your formula test, which we will take after spring break. And now we're going to try to use this formula to find the area. And I'm going to start off with the easiest one besides the triangle and the square. I'm going to start off with the easiest one in your notes, and so I've added this question. We're going to work this 2 ways. I'm going to show you 2 different ways you can work it. It is special. The first way we're going to work it only works for a hexagon. So on your notes, put only for a hexagon. This is the shortcut. And then I'm going to show you what we could do for any polygon. So for the pentagon, the octagon, the heptagon, the dodecagon. But a hexagon's special, and there's a little easier way to do it. So let's think about our hexagon here. I'm going to draw this hexagon. You draw it on your paper too. So only for a hexagon, this is something we can do. And we need to understand why we can do it. So first of all, we have our center. I want you to think about all of these radii that we're drawing in our hexagon. So draw all the radii in there. And I'm calling them radii because if we put a circle around that circumscribed circle, those would be radii of the circle, right? What's going to be true about all of the radii in our polygon? They're going to be congruent. That's going to be true for every regular polygon. So you're always going to have what kind of triangles in your regular polygon? Not necessarily equilateral, but they're always going to be isosceles. Do you see how there's two congruent sides for sure? Yes, but that doesn't mean that they equal the lengths of the radius. That just means that all of these sides are going to be the same length. Okay? Now the hexagon's special. But for every regular polygon, do you guys see that you're always going to have isosceles triangles? Are we agreed there? Okay, so that's going to be for a pentagon, octagon, they're always going to be isosceles. Okay, first thing we want to do is find our central angle. We need to know what kind of isosceles triangles we have. So remind me again, how do I find my central angle? 360 divided by the number of sides. How many sides do we have here in a hexagon? 6. So what's the central angle? 60. Okay, now look at what happens. If we make that central angle there 60 degrees, and this is why the hexagon's special. This goes back to what you learned last semester. If this is 60 degrees and this is isosceles, what do we know about these base angles? They're the same. Okay, what do they have to equal then for this to be 180 degrees total? Because if I take 180 and subtract 60, what am I left with? 120. And if I take 120 and divide it by 2, what does that make each angle? 60. If every angle is 60, then what kind of triangle is this going to be? Equiangular, which means it's also equilateral. That is only true for the hexagon. The pentagon, the octagon, the dodecagon, they're only going to be isosceles triangles. But the hexagon's special. The hexagon is actually going to end up being equilateral. So now all of the sides are equal. Okay, new today we learned a formula. The formula we learned was for an equilateral triangle. So for the hexagon only, the easiest way to find the area of a hexagon is to find the area, this is for the hexagon, write this down in your notes, to find the area of one of your equilateral triangles and multiply it by how many there are. How many triangles are there? 6. That's the easiest way. What's the special formula we learned today? Landon, say with me. What's the special formula we learned today for equilateral triangles? S squared, square root of 3 over 4. And we're going to multiply that by 6 of them because there's 6 triangles. Now again, this is only for what kind of shape? Hexagon. You can find the area of one triangle times how many there are for any of them, but the only shape that's going to have equilateral triangles is the hexagon. Okay? So if you want to work it this way, this is the easiest way. You use your special formula for an equilateral triangle and you multiply it by 6. Read the question. It said find the area of a regular hexagon with a side length of 6. So that means every side we have here is 6. So we're going to put 6 on every side, which means in our problem for the area, what's going to go in for the S? S stands for what? Side. And what's the side length? 6. So we're going to put 6 and square it. Multiply it by the square root of 3. Divide it by 4 because that's our formula. And then that's one triangle, and we have how many? 6 of them. So we're going to multiply that by 6. Look at the directions. How does it say to leave your answer? So you need to be really careful that you're not typing in that square root into your calculator. You can do little pieces or just use your head, but don't type it all in on your calculator. So let's start doing little pieces. What is 6 squared? 36. So we have 36 square roots of 3 over 4, and all of that is times 6. Simplify. What is 36 divided by 4? 9. So this becomes 9 square roots of 3 times 6. Treat your square roots just like an x. Pi and square root, treat them like an x until you're ready to type them in on your calculator. So if this were 9x times 6, what would you multiply? The 9 and the 6. So leave the square root at the end and just multiply the 9 and the 6. What's 9 times 6? So we have 54 square roots of 3. It said leave it in simplest radical form. That simplest radical form, do we have any units? Nope. If we did, we would have to include our units and square them, but we don't, so this is our area. Easiest way to find a hexagon is 6 equilateral triangles. Only works for a hexagon. Questions on what we did here? Okay, now we need to work it the other way because this is only for hexagons and you're going to have to find all kinds of shapes. So what I'm going to show you is harder, but it's what you're going to have to do for every other kind of polygon anyway. It's just going to be easier to understand because we already know what the answer should be, so we can compare and see if we did it correctly. So on your paper, if you're watching the video, I'm going to write this on the whiteboard. Look at the filled in notes. Okay, everybody with me on their paper? Have to write this down. This is the hardest part of the day. So write this down with me, okay? Area for a hexagon. For any regular polygon, what's the new formula for today? Any regular polygon. 1/2 AP. Lowercase a, capital P, apothem times perimeter. So you need to find two things to find the area. You need the apothem and you need the perimeter. In our picture, we have a hexagon. We know the side length of the hexagon. What's the side length again? 6. So we know that since it's regular, every side is 6. So the first thing we need to find, the perimeter, should be pretty easy. How would we find the perimeter of this hexagon? 6 times S. Because we have 6 sides, so it's going to be 6 times 6 because each side is 6. What is 6 times 6? 36. That's pretty easy so far, right? Okay, plug it in over here. 1/2 apothem times perimeter, but our perimeter is going to be 36. Okay, the perimeter is pretty easy if they give you the side length. Here's the hard part. Finding the apothem. So now we have to draw in our apothem. Where does our apothem go from? The center. So first we need the center. Where does it go to? The base, but we have to draw it perpendicular, right? So there's our apothem. The next thing you're going to have to do is find your central angle so you know what kind of triangles you have here. We already know what it is because we already did it over here on the smartboard, but central angle again is 360 divided by how many sides you have, which was 6. So what was our central angle? 60. We already did that. So that's the next thing you would do is find your central angle and then draw it in. Remember, your central angle goes from the center to 2 consecutive vertices. So this whole thing right here is the central angle. Are we okay with that? So when we draw in our apothem, what does our apothem do to that central angle? Splits it in half. So that means now this right triangle here that I'm going to draw really dark in purple, this right triangle, what's the measure of this angle right here? 30. And if this is 90, what's this angle right here? 60. So now we're back to the bell work, making sure that we can use a 30, 60, 90 triangle. If this whole side was 6, when I draw in that apothem, what does it do to this base again? Splits it in half. So what is this little piece of this triangle going to be? 3. And this little piece will be 3. So now what I would suggest you do when you're working these problems on your homework is I would draw that special right triangle, or whatever kind of right triangle you have. I would draw it separate from my picture. It's going to make it so much easier. Label what you know. This is 30. This is 60. This side is 3. And what do we call this side? The apothem. So this is A. And what we're trying to find is the apothem. So now work what we did in the bell work. What's across from the 30? L. What's across from the 60? L square roots of 3. We don't really need across from the 90 because all we're looking for is the apothem. So if L is 3, what is our apothem going to be? I'm hearing someone say it, but I'm only hearing this side. Everybody with me? What's A going to be? 3 square roots of 3. So once you have your A, you just plug it in up here. 1/2, 3 square roots of 3 times 36. And then you multiply and treat your square root like an x until the very end of the problem. Okay, so what's half of 3? 1.5. What's 1.5 times 36? 54. So we have 54, and what's going to go at the end of 54? Square root of 3, because we're not plugging that in on our calculator since it said simplest radical form. So 54 square roots of 3. If we had units, we would put units squared. We don't, so this is our answer. Same thing we got over here, doing it the shortcut way. Shortcut was 6 equilateral triangles. The long way was using 1/2 apothem times perimeter. When you do 1/2 apothem times perimeter, you have to find your central angle to know what kind of right triangle you have. If it's a special right triangle, you're going to use your special right triangles. Perimeter, you're just doing however many sides you have times the length of the side. All right, let's try a harder one. Last one for today, this one. Area of a regular, did I give you 2 more problems? Let me see which one's the hardest. I'm going to do the easier one of the 2. So give me just a second. Okay, I think that this is fine. We'll do this one. Area of a regular heptagon. Okay, guys, do not tune out on me. This is super important. This lesson right here will determine whether or not you're successful in all of Chapter 11. Not Chapter 10, Chapter 11. You're going to be taking these bases that are going to be squares, triangles, hexagons, octagons, decagons, and you're going to make them 3-dimensional in Chapter 11. And you're going to be finding the volume and the surface area. If you can't find the area of one heptagon, you sure can't find the area of a heptagonal prism. And you're going to have problems like that in Chapter 11. It is not going to get easier. You can't just go, oh, I don't get this. It's one thing. I'll just won't worry about it. You have to get it. So if you're not following, ask questions, come in, but this is vital to be successful, okay? So starting with what you learned last semester, what's a heptagon? How many sides? 7. You can draw a 7-sided shape. Sometimes that's hard for students to draw a 7-sided shape. Do your best. I'm not very good at it either. But you need 7 sides, so 2, 4, 6, 7. It should be regular, so they should all be equal. But ultimately, we didn't really use our whole hexagon, did we? What did we really focus in on inside our hexagon? One triangle. Do you see how we really did everything in just this one triangle? So if you get stuck on the homework, you might do your best to draw whatever shape it is, but then ultimately you're really going to focus in on one triangle. So draw one triangle in your picture. So center to two consecutive vertices, create one triangle. We're trying to find the area of a regular heptagon with a side length of 2. So now we know that all of these sides are 2. So draw your picture, then focus in on one triangle, and then write your formula down. So what's your formula for area of any regular polygon? 1/2 apothem times perimeter. If you'll say it and write it, it'll start to stick. 1/2 apothem times perimeter. You only need two things. You need the perimeter and you need the apothem. Start with the perimeter first. That's probably the easiest in this picture. How am I going to find the perimeter of this 7-sided figure? 2 times 7. There's 7 sides, so we'll just do 7 times each side, which is 2. What's 7 times 2? 14. We're going to take that and we're going to plug it in for the perimeter over here. So we have 1/2 apothem times 14. Not too bad so far, agreed? Okay, the next thing we have to do is focus in on our one triangle to try to find the apothem. Remember, the apothem is just basically the height of your triangle. So we're going to focus in on this one triangle. We're going to draw in our apothem. Use a different color. So draw in your apothem. But what are we going to need to find before we can figure out what kind of right triangle we have here? Okay, reset it, the central angle. Remember, the second thing, or at some point before you can go any further, you've got to find out what kind of triangle you have. So you have to find the central angle. All right, so to find your central angle,
for Encore in room 153 will also need to go to the library. Please remember the students who are taking the morning nap test in the seminar room at this time.
it's called the NAEP test, not nap test. I would like a nap test. How about you guys would like a nap test? Let's all go take a nap. Yes, I'm pretty good at nap testing. All right. Remember, central angle is just simply 360. Keep in your mind why, and that'll make it make more sense. Because really, when you put all those together, that makes a circle. 360 divided by how many sides you have. So what are we going to do? Divide by 7. Take your calculator. What's 360 divided by 7? 51.4 exactly. Do we round in the middle of a problem? No. Take your calculator and change that back to a fraction. Do not round in the middle of the problem. Say it again. If it's a problem on your homework, you cannot round, so you're going to need to leave it as a fraction, which when you change it back right now, you're going to see that it changes back to what? 360 over 7. So you didn't need a calculator. Just leave it as 360 over 7, okay? So 360 over 7 is the measure of that angle. This is a little harder because it's not a nice, pretty number, but it's just an angle, okay? Now we're going to take this 360 divided by 7 angle, and we're going to divide it into 2. Because we're going to draw in that apothem. When we divide this angle by 2, take your calculator. What's 360 over 7 divided by 2? So again, it should have given you a decimal, but you're going to go back and change it to a fraction, which is the same as. So we're going to divide it by 2, which is the same as multiplying by 1/2, and you should have gotten 360 over 14, which is 180 over 7. Again, you don't really need a calculator, but you can use your calculator to get there. So we're going to focus on one of these right triangles. One little right triangle. I'm going to redraw it separately and larger so you can see it. So one right triangle. I'm trying to find the apothem. And I know this angle right here is 180 over 7 degrees. Okay, don't let that mess you up, that it's not a perfect pretty whole number. Okay, just like when we had 60, we divided it by 2, we got 30. This was 360 over 7, we divided it by 2, we got 180 over 7. Are we good? Okay. So now, this is our angle. Don't forget that this was 2 to start with. When you drew in the apothem, what did it do to that 2? It bisected it. So what does that make each little piece here? 1 and 1. So down here, this is 1. Are we good with that? Okay, guys, this goes back to what we learned last chapter. Do we have a special right triangle in this problem? No, it's not 30, 60, it's not 45, 45. So what did we do last chapter when we knew an angle, we knew a side, and we were looking for another side? SOHCAHTOA. So again, today's lesson's hard because it reviews all of these things. But we're going to have to use SOHCAHTOA to find A. This is not tough. Just do what you did last chapter. SOHCAHTOA. And if you struggled last chapter, then you need to come in and let me help you. So we know this angle, what do we call the side across from it? Opposite. What do we call the side next to it that we're trying to find? Adjacent. Which trig function uses opposite and adjacent? Tangent. Okay, I'm going to go to the whiteboard. If you're watching the video, look at the filled in notes. So on the whiteboard here, erase this. We're going to do tangent of what angle? 180 over 7. Because we don't want to round until the end, so we're going to leave that nice 180 over 7. Equals what over what? 1 over A. Opposite over adjacent. Okay, depending on how you did it last chapter, you either put this over 1 and cross multiplied, or the video had a little trick that said when X is down below, you switch, you know. So you could use that method if you want. Either way, if you cross multiply, you're going to get A times the tangent of 180 over 7 equals 1. And then what are you going to do to solve for A? Nope. What am I going to do here to solve for A? Divide. And that's why in the video it says you switch these, you know, because this ends up going down below. So we're going to divide by the tangent of 180 over 7 on both sides. Those cancel. So that tells us to divide. Now we're ready to use our calculator. Just keep in mind this is not your answer though. So when you use your calculator and you get this 1 divided by tangent of 180 over 7, you want to be real careful. That's your value for A. What are you going to do once you have your value for A? You're going to plug it in here, so you're going to multiply it by what? 1/2, and then by 14. Or what is half of 14? 7, so you could just multiply it by 7 all at once if you want. Okay, so grab your calculators. Let's do this together. Last thing. Stay with me. And again, if you do not have a good calculator to work with, if you have problems like this, set them up on your homework and then come into Encore, come before school, use one of mine, or ask to check out a scientific calculator before you leave. I can't check out the graphing calculators, but I can check out the scientific ones I have. Sorry, it's taking just a minute for mine to load up. Okay, here we go. Typing it in with me. So we're going to type in this 1 divided by, everybody do it so you can practice. 1 divided by tangent of 180 divided by 7, close parenthesis. Did everybody have theirs typed in correctly? Hit enter, and that is your value for A. If your calculator's in degree mode, did you get the same thing I did? Make sure your calculator's in degree mode. Mine is in degree mode. If yours is not, go change it, and then do it again. Okay, this is what we have for A. Everybody with me? Anybody not get that and need me to help see where they went wrong if their calculator was in degree mode? Okay, once we have A, we're plugging it into our formula. 1/2 apothem times 14 for the perimeter. So we're taking this value and plugging it in. So we're just going to take that number and multiply it by either 1/2 and then 14, or I would just do times what? What's half of 14? 7. So we just hit times 7. It brings back that answer. Hit enter. And what do we get according to the directions for this problem? To the nearest tenth. 14.5. And did it give us units? Feet. So our final answer on our notes would be 14.5 feet squared. Okay. Listen to me carefully to make sure this is making sense, okay? If you have a square and you have enough information, I would just do A equals side squared. However, you could do 1/2 apothem times perimeter because it is a regular polygon. If you have an equilateral triangle, I would use S squared square root to 3/4. But you could use 1/2 apothem times perimeter, depends on what they give you. If it's anything else, a hexagon, an octagon, a decagon, you're going to have to do it the long way, you're going to have to find the central angle, cut it in half, and then look at your right triangle. If it's special, you're using 30, 60, 90, 45, 45, 90. If it's not special, you're using trig. Don't round until the end. Questions?